All right, we're doing worksheet 19 today, and we have our triangle congruent statement identifying the congruent triangles. They've even marked it for us, and they said identify the corresponding parts. We should have 3 corresponding angles and 3 corresponding sides. So angles, well, angle X is congruent to angle N. And angle Y is congruent. There's one mark there and one mark there to angle P. But it could also pair up the X and N and the Y and P. And then angle Z is congruent to angle Q. All right, so there's my angle congruent statements. Let's do our sides. XY has 1 tick mark, which matches with PN. And YZ is congruent to PQ. Make sure you have your segment symbols. And the last one is XZ, which is congruent to QN. Okay, so let's move on and talk about our new things today. Instead of needing to show that all 6 corresponding parts are congruent, the 3 angles and the 3 sides, to prove the triangle is congruent, we have postulates that are developed. So we only need 3 specific congruent corresponding parts, but we have to have specific ones. So the word included is going to be really important for us. The word included is frequently used when referring to the angles and sides of a triangle. So what does included mean? Angle B right here is included between sides AB and BC. So if I highlight these 2 sides, do you see that angle B is formed by them? So these 2 sides come together and angle B is between them. So something that is included for an included angle, it is the angle between 2 sides. The angle between 2 sides. They create the angle. Those 2 sides create that vertex. And so if you think about side AB and side BC, do you see that they both go to B? And that's why that's a shared angle. All right, so we have some examples. And I know this seems like a little thing, but it actually makes a big difference because it's how we prove things. So look down here. What is the included angle between NC and AN? Okay, so here's NC. I'm going to trace that in red. And AN is right here. So what's the included angle? Well, between NC and NA is angle N. Again, do you see that they both have the N in their side? That's how I know it's right there. What's the included angle between AC and AN? Without even doing it, guys, do you see that they both have an A? So here's AC. I'll highlight that in blue. And here's AN. Do you see they come together right here in blue to form angle A? All right, now, angle C. If I'm looking at angle C, what is angle C included in? Here's angle C. Well, angle C is formed by the line CN, so segment CN, and segment CA. Now, these aren't congruent, guys. We're talking about the parts here. So if I'm looking for angle C, it's between NC and CA. And again, see, they both have the C there. So included is between these 2. It's not bouncing around. All right, next page. So we have 4 postulates we're using. And this is one of them. We're only doing 2 today and 2 in another lesson. We call this side, side, side. And we shorten it to SSS. It literally means exactly what it says. 2 of these triangles can be congruent if all 3 sides are congruent. So if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. So let's mark this. This triangle has a 4 centimeter side, and this triangle has a 4 centimeter side. Okay? This has 6 centimeters, and this also has a 6. And the 7 centimeters pairs with 7. So you can see that we have 3 sets of congruent sides. So that's all I need to prove it. So if I have 3 sets of congruent sides, then I also have 3 congruent angles, which means I have 3 congruent triangles. So what's my conclusion? Well, triangle ABC is congruent to what? Triangle ABC is congruent to, all right, did you name it right? Let's see. I did A, which was formed by the 4 and the 7. So you said F, I agree. I did B, which was formed by the 4 and 6. So D, and then E. So the order does matter. So triangle ABC is congruent to triangle FDE by side, side, side. Okay, we're not going to get heavy into proof since this isn't a full year geometry course, but we are going to do some together to practice them and to show you what they are. So congruent sides are marked with tick marks, just like we did. And if you need to prove side, side, side congruency on the coordinate plane, we would use a distance formula, which we did the other day. All right, now, we're not having to do that today, but if we don't know what the sides are, we can always find them using the coordinate points. So we're going to do a proof here. In marine biology, the tail of an orca whale can be viewed as 2 triangles that share a common side. So you can see the whale fin coming out there. Write a 2-column proof. So there's proofs that are written as paragraph and there's 2 columns. So any of the ones we're going to do are called 2-column. Here's the statement. Here's what we need to have, and then we have to say why. So this is a little different. Now, let's read up here, and if you can look closely, you can see the labelings here. It says prove. This is what we want to prove. So what we want to prove is in the last statement. That's my goal. I got to get there. What do I know? I know that AB, which is right here, here's AB. And you know, let me redraw this. That might help. Okay, let's redraw this. This is A, this is B, Y, and C. Okay, so with that in mind, that might help us to have the picture drawn. It says that AB right here is congruent to AC. So mark those for me. And then BY up here, 2 tick marks, is congruent to CY. Now, they gave us this in the direction. So look right here. See how it says given? They gave us these congruent sides. So the reason that we know this is it was given. They have to give you something. Like they have to start you off with some rules. Now, in order to use the side, 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 I need all 3 sides. So I have this set, I have this set, I have one more side. Does anybody remember why this is congruent? There was a term I used. I marked it like this with an X. And I said YA is congruent to itself because it's the same segment on both triangles. Does anybody remember the term for that? It was the reflexive property. Okay, so I'm not going to be picky on properties in here because it's not a full year course. But why is AY congruent to AY? It's congruent because of the reflexive property. And I'm just going to say side AY is congruent to itself. Okay, so normally they would only give you the given and ask you to prove this. They wouldn't tell you extra information, but they were leading us here. Now I have the 3 sides, right? So my triangles are congruent because BY matches with CA. All these match up. They're congruent by the postulate side, side, side. So they gave us 2 pieces of information. We remembered this shared aside, so it's congruent to itself, and now we have 3 sets of sides. So that was a pretty simple 1-step proof. All right, now we have another theorem. And the next theorem is side angle side, or SAS. All right, so having this is really big. See that angle here? Put the word included there. So it's not just 2 sides and an angle. It has to be 2 sides with the angle in between them. So here is side A and B, or sorry, AB and AC. See how they come to that included angle? And these have an included angle. So we have a congruent side, the included angle, and then the very next side. That makes it side angle side. So my statement is that triangle ABC is congruent to triangle. Okay, now we have to match this up. A goes with E. B right here goes from the one tick to no tick right here, F. And then the last one is C, which goes with D. And there you go. And those are congruent by side, angle, side. Okay. Down here is just a little reminder. Congruent angles are marked with arcs, so that little sort of curve in there. All right. So now we've got a little bit bigger of a proof. Again, this is called a two-column proof. Normally, none of this would be here. They would only give you this information and then tell you to prove this. And you'd be on your own to sort of think of all of these ideas. But we're just introducing this idea of proofs. So what do they give us? Well, they tell us X is a midpoint of BD. Guys, here's BD. Midpoint is exactly what it says. It cuts it in the middle. We did midpoint a while ago. Midpoint means that this part of the segment is congruent to this part of the segment. So if X is the midpoint of BD, X cuts it in half, and we have two equal pieces. All right, well, X is also midpoint of AC. Now, BD is stretched out in this parallelogram. AC is shorter, so this is congruent here. So they're not all congruent. It's just this is split in half, and that's split in half. All right, that's all we know. So X is midpoint of BD, that was a given. And they split it up. X is midpoint of AC, that was a given. Now, the next thing it says here is that DX is congruent to BX. Isn't that what we just said? So we would have to state that. Why did they give me this? So I can split it in half. Why is DX congruent to BX? I'm just going to say definition, DEF apostrophe N, definition of midpoint. That's true. I mean, that's why they were congruent. It's called the definition of a midpoint. Then they did the same thing. We talked about this being a midpoint of AC. We talked about how it split that in half. So that is also definition of midpoint. All right, now it's telling us and it's helping us out that we have congruent angles. All right, first of all, what was I trying to prove? I guess I should have focused on that. I'm trying to prove that triangle DXA, this triangle up here, is congruent to triangle BXC. So do I care about these other sides out here? I don't really care about those sides. But do you see, if I can ignore everything else, do you guys see that bow tie look? And couldn't I mark this angle congruent to this angle? Do you remember why these angles are congruent? Remember the term for that? Vertical. Linear pair would be these two adding up to 180. That's your linear pair. These would be vertical. Oh, did you say vertical? Oh, vertical pair. Yeah, vertical pair or opposite angles. Yes, I'm sorry. I heard pair and I was thinking linear pair. That's called a vertical pair, and they're congruent, or opposite angles are congruent. So when it says angle DX, oh, here it is, sorry, DXC, this one here, is congruent to angle BXA right here, that's called a vertical pair or vertical angles. Vertical angles are congruent. My only problem is they want us to prove, oh, I traced the wrong triangles, guys. I'm sorry. They wanted us to show something different, and I traced the wrong triangles. We are supposed to be proving triangle DXC. DXC is congruent to triangle BXA. I did the top and bottom. Sorry about that. That's what I was supposed to be proving. So that's why we have this angle is congruent to that angle. We could have proven the other ones too. Okay, well, now that I fixed that, my apologies. Why are these triangles congruent? Well, do you see that you have this side an included angle and this side? So sorry, this side included angle and this side. So side, angle, side. All right, so I totally traced the wrong triangles. Same idea though. All right, let's move down here. We're only focusing on these two. So can I prove it by side, 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 angle, side? And sometimes it's not possible. So looking at this, do you guys see that we have three sides marked? Do they match up? This side matches, and this side. So yes, I would say they are congruent by side, side, side. And it says, if so, write the congruence statement and identify the postulate. So here's the postulate, side, side, side. Congruent statement, triangle GHI is congruent to triangle what? Okay, well, G goes with Z, H goes with Y, and I goes with X. Now, can I prove number 2 is congruent? Well, can we agree that I can't use side, side, side? I know 2 sides, don't I? Do I know the third side? So it's not side, side, side. Do you notice that I know a side, an angle, and another side? This is considered an included angle, isn't it? So it is side, angle, side. And we would say triangle, I'll go with BCF, is congruent to triangle what? Okay, I started with B, which has the 1 tick mark in here. So I'm going to go to E. C is in the middle, which works there. And then D goes with F. Okay, so there's my postulate, and there is my congruence statement. So we have a couple more to practice. All right, so we are only using SSS today and S angle S. So I need you to take a minute, and I need you to try these. You're going to try these and pause this video. All right, so looking at these, we're trying to determine, now I have 2 sets of sides marked, but you guys see that this is congruent to itself. So I really have 3 sets of sides. These two, and this is congruent to itself. So these triangles are congruent by side, side, side. The triangle congruent statement is triangle JKM, and we need to pair it up. So I started with J, I'm going to start with L to triangle LKM. All right, how about number 4? Well, here's what I do know. I know this side is congruent, and I know this is congruent to itself. But do I have a third side? It doesn't matter that they look congruent, that's not marked, and we're not told anywhere. So we don't have a third side. Do I have an angle included? No. So this is not possible. As in, they could be congruent, but it's not possible for us to prove it. Does that make sense? So when I say not possible, it's not possible for us to prove it. All right. Number 5 I thought was pretty self-explanatory because we can see very clearly the 3 sides. There's no angles marked. It's 3 sides. So this one is side, side, side. Triangle ABE is congruent to triangle CBD. So A to BE, C to B to D. Okay, how about number 6? I can't do side, side, side because I only have 2 sides. I don't have the third. Is this an included angle? Okay, see how the angles between the 2 sides? That has to be there. So yes, this is included angle. So this is side, angle, side, side, angle, side. And then once you do this, you have to do the triangles of M and Q is congruent to triangle ONP. Okay, if you didn't finish this worksheet, try the rest of them. So in number 7, I see a side and an angle marked, and actually a 90-degree angle. Do you guys see that this side is shared? Do you see that there? So we do have a side, an included angle, and a side, and these triangles are congruent. It is triangle PQS, which is congruent to triangle RQS. Honestly, the triangle congruence statements, that's what takes a little time. Okay, how about number 8? At first glance, I see side, angle, side, and that's what I was thinking, but this angle is here. That would be the angle I need. Do you see it? This works with side, angle, side. Guys, this spells a swear word, ASS, and that is not one of the options. It wasn't an included side, so this one is not possible. All right. Next one. Does it match up properly? 1 tick, 2 ticks, 3 ticks? Absolutely. So side, side, side. And this would be triangle PQR is congruent to triangle BTU. Okay, last one. Guys, I see 2 sets of sides, and I don't see the third matched, and it doesn't share it. So it can't be side, side, side. Can it be side, angle, side? Why not? It doesn't have an angle, but is there an angle that we know? What? See that bow tie effect? See that angle here and here? So I cannot make something up. I can't say, well, these look congruent, but this is a vertical angle or a vertical pair. And vertical angles are congruent. So I didn't just make it up. I know that. So yes, this would be side included angle side. Side angle side, and its triangle XYZ is congruent to triangle BWZ. Now, real quick, I just said that, and someone might be like, well, look up here. Up here, I can mark that this angle is congruent to this angle, but that still doesn't help me. This I know nothing about, and I needed the included angle there. All right.